Hello everyone. This lesson we're going to talking about the calculation for three-phase open delta auto transformer. So open delta auto transformer, we know we only need a two transformer connecting open delta. So this time I'm use two single-phase isolation transformer. Each was rated 120 volt, 480 volt, 6 kVA each. Single-phase isolation transformer. I connect those single-phase isolation transformer as an auto transformer. I use two of them to make the open delta connection. So here's a picture. I like to draw those open delta auto transformer. I connect X1, X2, H1, H2 of one transformer together as one of the open delta auto transformer. Then I connect another one the same way. The common point in the center, the two H2 connect common point, that's going to be my one of the line connect between the primary side and the secondary side, or the high voltage side and the low voltage side. The X1 two terminal of each transformer going to be connect onto the high voltage side, and the low voltage side going to make a connection between each transformer's X2 and H1, because we connect those isolation transformer as auto transformer, so we have to connect the high side and the low side together. In that common point, I'm going to bring out one of the wire for my low voltage side. So here's the connection diagram. From this connection diagram, I can see between X1 and X2 will be 120 volts, and between H1 and H2 will be 480 volts. So by this connection, when I connect X1, X2, H1, H2 together, I can get 600 volts on that side. On this side, I will only have 480 volts. It's a three-phase auto transformer, so I have three lines, line A, line B, line C, and here's my line A, line B, line C. So I will use them as three-phase supply. Now let's look at the calculations. For those three-phase open delta auto transformer, the calculation we all have to look is, if we look at the current direction first, my high voltage side line current coming in have to go through this winding X1, X2. Then the low voltage side, the current gonna come out from here. So because I know for the transformer, kVA in equal to kVA out, the low voltage side will for sure have more current. So I know in this common portion of the winding, which between H1 and H2, the current direction have to go that way, because for these two current to add up to equal to the low voltage side current. It's because this winding is in series with my high voltage side, the line current. That will make this calculation become much easier. So here is the idea I gave to you. Because the transformer X1, X2 winding is in series with the high voltage side, the line current. So the maximum current on the high voltage side will only be limited by the current rating of this X1, X2 coil. So if I find out what's the X1, X2 coil, the rate of the current, I will know what's the maximum current on the high voltage side. That's my calculation to find this current, because it's each individual transformer, use the kVA divided by the voltage rating for that coil, 6 kVA, 120 volt, give me 50 amps. That 50 amp, because this coil can handle maximum 50 amp, so this current maximum is limiting to 50 amps. That's the current on the 600 volt side. I know the 600 volt side maximum current will be 50 amp. If I know that, then I can calculate the maximum load kVA will be root 3 times E line times I line, gave me 51.96 kVA. So that will be the maximum kVA this auto transformer can handle. If I over this one, the high voltage side will have a current more than 50 amp, then I'm going to burn out the transformer winding X1, X2. So that's my maximum kVA of the load for this transformer bank can supply. Then my low voltage side current, because I already know the maximum kVA of the load, I can calculate the low voltage side. What's the current? 62.5 amps. So this side, we draw 62.5 amp. That side is maximum 50 amp. Then the common winding current will be the difference between these two currents. So for common winding current, it's 62.5, subtract 50, give me 12.5 amps. So this way, the calculation is very simple. Also, you can see, I only use two 6 kVA transformer. I can handle a load to 51.96 kVA. It's because for auto transformer, part of the energy is using the transformer function to transfer to the load, and another part of the energy is conduct directly through this line to the load. So auto transformer, you can always have more kVA of the load on the smaller kVA rated transformer. I'll give you another example. If I have a total 100 kVA of 3-phase load, I want you to find out what's the minimum kVA for those transformers will be able to handling this load. So the same thing, because if I have a 100 kVA of load, I need have this current down here will be the same of the current this X1, X2 coil going to be handled. So I find my high voltage side current, kVA divided by root 3, divided by the voltage, give me 96.2 amp. And that 96.2 amp have to be able to carry by this transformer X1, X2 winding. So if I know that X1, X2 winding have to be handled that much current, then I know the transformer's kVA will be the voltage for that winding times the current for that winding. I require 11.55 kVA of the transformer rating to handle that 100 kVA of the load. The secondary side, or the low voltage side, the current will be also 100 kVA over root 3, the line voltage, 120.3 amps. Now, with these two current, I can calculate what's my common windings current equal to these two currents subtract each other, give me 24.1 amps, because the transformer, the kVA in gonna equal to the kVA out. So on the low voltage side, you're always gonna have a higher current than the high voltage side. So the common windings current is always the low voltage side, the line current, subtract the high voltage side, the line current. After that, I just want to mention to you, you look on this diagram here, I didn't give you which side is the supply, which side is the load. So for this open delta auto transformer, I can have the supply on this side, use a step-up transformer, put my load on that side, or I can use it as step-down transformer, put my supply on there, and put my load on here. But for the calculation of this open delta transformer, it doesn't matter which side is the load, which side is the supply, because all I care is how much current gonna go through this portion of the winding. This portion of the winding is always in series with my high voltage side. So as long as I can find out that current, everything, the calculation will become much easier. If you have any question, connect us online or send us emails.